Question 1. To illustrate this point, a technician named Mr. Alvarez is called to a commercial building where the HVAC system has lost efficiency and cooling capacity. Upon connecting his manifold gauges, he notes the system is running at significantly low suction pressure. A visual inspection shows oil accumulation near a flare fitting. Before proceeding, what is the most appropriate next step for Mr. Alvarez? A. Immediately recharge the system with additional refrigerant to restore pressure. B. Use nitrogen pressurization followed by electronic leak detection to locate the exact source. C. Replace the suspected fitting without further testing since oil presence confirms a leak. D. Pull a vacuum and monitor microns to verify leak presence. Answer. Correct answer. B. Explanation. The correct course of action is to pressurize with nitrogen and use electronic or ultrasonic detection. Oil near fittings suggests leakage, but precise identification ensures proper repair. EPA 608 requires technicians to verify leaks before charging or replacing components. Pulling a vacuum D verifies evacuation, not leaks. Recharging without leak repair is illegal and unethical. Replacing without testing C can result in missed or incorrect repairs. Follow EPA 40 CFR Part 82 guidelines for leak detection and verification procedures. Question 2. Throughout the course of an airflow audit in a commercial office, Ms. Patel discovers several rooms with inconsistent temperatures. She measures airflow at each register and finds certain areas receiving only 50% of the design CFM. What is the most likely cause of this airflow imbalance? A. The refrigerant charge is slightly low, affecting overall airflow. B. There are improperly sealed or collapsed ducts in the distribution network. C. The thermostat is not correctly sensing room temperature. D. The compressor is short cycling due to low outdoor temperatures. Answer. Correct answer. B. Explanation. Inconsistent CFM delivery is most often due to duct issues such as collapsed flex ducts, disconnected branches, or leaks. Low refrigerant they affects cooling, not airflow balance. Thermostat errors C may cause uneven temperatures but do not explain measured airflow differences. Compressor cycling D affects system runtime, not individual room airflow. Manual D occur and SMACNA guidelines emphasize importance of duct integrity in maintaining balanced airflow. Question 3. In light of recent developments, Mr. Koji is troubleshooting a rooftop unit that intermittently shuts off. He finds the high pressure switch tripping under full load on hot days. What should be his next diagnostic step? A. Bypass the high pressure switch to allow the unit to operate. B. Measure condenser coil temperature and check for airflow obstructions. C. Increase refrigerant charge to boost head pressure. D. Disable the economizer mode to reduce system strain. Answer. Correct answer. B. Explanation. A tripping high-pressure switch often indicates airflow restrictions or dirty condenser coils, especially in hot conditions. Mr. Koji should check coil cleanliness, fan operation, and ambient airflow. Bypassing is dangerous and violates NEC 440.21 and OSHA 1910. Adding refrigerant C raises head pressure further. Disabling economizers D is unrelated to condenser performance. Proper diagnosis must follow ASHRAE 180 maintenance and diagnostic protocols. Question 4. When evaluating the merits of a preventive maintenance program, Ms. Gomez implements seasonal inspections for a 100-ton package system. Which of the following best reflects the primary goal of her maintenance strategy? A. To comply with federal inspection requirements. B. To delay major equipment replacement as long as possible. C. To enhance energy efficiency and reduce unplanned downtime. D. To keep warranty documentation updated. Answer. Correct answer. C. Explanation. Preventive maintenance aims to optimize system performance and avoid unplanned failures by catching issues early. While compliance and documentation are important, the main driver is to increase energy efficiency and reliability as detailed in ASHRAE Standard 180. Delaying replacement B is a consequence, not the goal. No federal law mandates seasonal HVAC inspections, though local codes may. Question 5. From a historical standpoint, Mr. Lang is asked by a client to vent a small amount of refrigerant during a condenser swap, claiming everyone does it. The job site is under no apparent supervision. What is Mr. Lang's best response under EPA guidelines? A. Proceed with venting since it's only small charge and won't harm the environment. B. Record the incident, perform the venting, and notify the office afterward. C. Refuse the request, recover the refrigerant properly, and educate the client. D. Do the venting discreetly since compliance is unlikely to be enforced. Answer. Correct answer. C. Explanation. Under EPA 608, venting refrigerants is strictly prohibited, regardless of charge size. Mr. Lang must legally recover refrigerant using certified equipment or risk fines. Educating the client upholds professional and ethical standards. Venting AD violates 40 CFR Part 82.154 and recording the Act. B doesn't negate the illegal action. Ethical technicians follow law and protect environmental integrity. Question 6. Taking into account the rise in mildly flammable R refrigerants, Daniels is tasked with charging the system using R32. What safety precaution must she take that differs from non-flammable refrigerant handling? A. Use only standard recovery machines approved for R400 TINA. B. Ventilate the workspace and avoid ignition sources during charging. C. Store R32 cylinders horizontally for stability. D. Dilute R32 with nitrogen to minimize flammability. Answer. Correct answer. B. Explanation. R32 is classified as an mildly flammable refrigerant. NFPA 70, ASHRAE 15, and IL 60335-240 require adequate ventilation and elimination of ignition sources. Using standard R400 TINA machines, they may not be approved for ALs. Cylinders should remain upright. C. Diluting with nitrogen. D. Is unsafe and non-compliant. Technicians must follow EPA and R32 guidelines for safe use. Question 7. By evaluating a fan system not starting in a split system, Mr. Nunes checks the capacitor and finds it swollen. What does this observation imply? A. The capacitor is operating at peak efficiency. B. The capacitor has likely failed and needs replacement. C. The motor is at fault and unrelated to the capacitor. D. The wiring is undersized and causing excessive voltage. Answer. Correct answer. B. Explanation. A swollen capacitor is a clear visual sign of failure due to internal gas pressure buildup. Capacitors are critical in motor starting operation, and failure can prevent fan start. NEC 430 and HVAC best practices suggest immediate replacement of failed capacitors. A swollen unit is not safe to reuse. Incorrect motor blame. C. Ignores symptoms. Wiring issues. D. Would show different signs. E. G. Melted insulation. Question 8. The predominant theory suggests that if a system exhibits low suction pressure and high superheat, what issue is most likely occurring? A. Overcharged refrigerant system. B. Blocked condenser coil. C. Undersized expansion valve or restricted metering device. D. Thermostat set point too low. Answer. Correct answer. C. Explanation. High superheat plus low suction indicates insufficient refrigerant flow, typically due to a restricted metering device. GTSV clogged. This reduces evaporator feed, causing high outlet temp superheat. Overcharge. A. Would raise suction. Blocked condenser. B. Raises head pressure. Thermostat. D. Doesn't directly influence metering behavior. C. HVAC system performance standards, CAP, and refrigeration cycle principles. Question 9. In the absence of written lockout-to-gut procedures, what is a technician's safest approach when replacing high-voltage component? A. Trust that the circuit breaker is off if the thermostat is off. B. Proceed cautiously if no movement or sound is detected. C. Physically lock and tag the disconnect and verify energization. D. Rely on coworker to watch the panel during service. Answer. Correct answer. C. Explanation. OSHA 1910.147 mandates lockout-to-gut (LOTO) procedures for safety. Technicians must physically isolate and verify power off before service. Trusting breakers or coworkers. A. D. Is unsafe. No movement. B. Doesn't confirm safety. Only C. Aligns with NFPA 70 and OSHA mandates for electrical safety. Question 10. While examining a walk-in freezer system, Mr. Clark notes frost buildup on the suction line all the way to the compressor. What underlying issue could this most likely indicate? A. The TSV is overfeeding refrigerant. B. The defrost cycle is operating too frequently. C. The compressor valves are leaking internally. D. The evaporator fan motor has failed. Answer. Correct answer. D. Explanation. Frost on the suction line to the compressor usually signals lack of air movement over the evaporator, commonly from a failed fan motor. Without airflow, refrigerant doesn't absorb heat, causing excessive frosting. Overfeeding A would result in liquid slugging. Frequent defrosting B wouldn't explain active frost. Valve issues C reduce pressure, not cause frost line extension. Refer to ASHRAE refrigeration troubleshooting guidelines. Question 11. Among the various failure scenarios in condenser fan motors, HRConquer observes a motor that hums but does not start even though power is verified. The capacitor tests good and there is no shaft binding. What should HRConquer suspect next? A. An internal short within the windings is preventing startup. B. The motor is incorrectly wired for the voltage supplied. C. The wrong capacitor has too high of a microfarad rating. D. The contactor is open on one pole, reducing current flow. Answer. Correct answer. D. Explanation. A humming motor with verified voltage and working capacitor may indicate a single-phase condition, often due to a failed contactor pole. This restricts current, preventing motor rotation. Internal winding shorts A typically trip breakers. Incorrect wiring B usually causes more dramatic symptoms, while a wrong capacitor rating C can affect torque. It wouldn't cause this exact symptom. NEC 430, which are troubleshooting guides stress full-phase voltage supply to motors. Question 12. With the advent of dual-fuel systems, Mr. Jacobs is inspecting a heat pump in heating mode that cycles excessively and struggles to meet the set point. Outdoor temps are near freezing. What is the most likely explanation? A. The backup heat source is not engaging due to thermostat configuration. B. The reversing valve is stuck in cooling mode. C. The outdoor sensor is improperly sensing above actual temperature. D. The TXV is overfeeding the evaporator coil. Answer. Correct answer A. Explanation. In cold weather, heat pumps need supplemental heat. If the dual-fuel thermostat isn't configured to engage backup heating, A. The system will struggle. A stuck reversing valve B would produce cooling, not poor heating. Outdoor sensor faults C can affect staging but would typically result in short cycling or no staging. TXV behavior D is not the core issue here. Refer to Manual H and Nate Duve. Set up procedures for proper staging logic. Question 13. The relationship between safe service and proper lockout procedures was demonstrated during a service call by his Franco. She isolated a rooftop unit by pulling the disconnect and locking it out. Before beginning work, what critical step must she perform next? A. Place a tag on the disconnect warning others of her presence. B. Test the thermostat to ensure the unit won't engage. C. Use multimeter to verify the absence of voltage at the terminals. D. Notify the customer that work has begun. Answer. Correct answer. C. Explanation. Verifying absence of voltage is the critical step before service. Per OSHA 1910.147 and NFPA 7 tie, lockout alone does not ensure denegization. Tags A are important but secondary. Testing the thermostat. B does not confirm electrical isolation. Notifying the customer. D is good practice but safety procedures take precedence. Proper PPE and multimeter are essential parts of safe electrical service. Question 14. During the process of diagnosing poor cooling, Mr. Simmons notes that the evaporator coil has uniform frost from inlet to outlet. Suction pressure is low and superheat is high. What is the likely cause? A. The indoor blower is not running. B. The system is undercharged or has a refrigerant restriction. C. The condenser fan motor has failed. D. The expansion valve is stuck open. Answer. Correct answer. B. Explanation. Uniform frost plus high superheat plus low suction suggests underfeeding of refrigerant, likely due to a restriction or low charge. If the blower failed, you'd see freeze up closer to the inlet only. Failed condenser fan C causes high head pressure. Stuck open TXB D would cause low superheat, not high. Refer to CAS system diagnostics guidelines for interpreting coil behavior. Question 15. Demonstrated by Eastern UN service report mixing oil with mineral oil during retrofit to R400 Tina caused system damage. Why is this practice unacceptable? A. Oil oxidizes more rapidly when mixed. B. PO and mineral oils create chemical reaction. C. The viscosity difference leads to oil pump failure. D. PO is hygroscopic and doesn't mix well with mineral oil. Answer. Correct answer. D. Explanation. Polyester oil is hygroscopic, meaning it absorbs moisture and is not miscible with mineral oil. This leads to poor oil return and potential compressor damage. There's no explosive reaction. B. And the viscosity differences. C. Exist but aren't the primary issue. Refer to RE700 and manufacturer retrofit guidelines, which specify complete oil change out when switching to PO-based refrigerant like R400 Tina. Question 16. The central argument for psychrometric analysis in HVAC is demonstrated when Hall evaluates latent versus sensible heat loads. Which tool allows him to determine these properties accurately? A. Thermocouple probe. B. Voltmeter. C. Psychrometric chart. D. Digital vacuum gauge. Answer. Correct answer. C. Explanation. The psychrometric chart graphically displays air properties like enthalpy, dew point, arch, and sensible heat ratio (SHR). Thermocouples A. Give temperature only. Voltmeters B. Are electrical vacuum gauges. D. Are for evacuation, not air analysis. Proper psychrometric understanding is foundational in ASHRAE fundamentals and Manual J for system design and load calculations. Question 17. While it is true that a system can meet the thermostat set point, Baker notices hot and cold spots throughout the space. He measures total airflow at the air handler and finds it correct. What is the next best action? A. Add a booster fan in the longest duct run. B. Just individual dampers to balance airflow across zones. C. Increase fan speed at the air handler. D. Reduce static pressure by shortening duct runs. Answer. Correct answer. B. Explanation. If total airflow is correct, the imbalance likely lies in individual duct distribution. Manual D. A CAT supports adjusting dampers to balance airflow to each room. Booster fans A. Add complexity, increasing speed. C. Might overfeed already balanced zones. Static pressure D. Isn't always practical. Proper balancing improves comfort and system performance. Question 18. Looking at the data on a wiring schematic, Clark observes that the fan relay coil is wired in series with a high limit switch. What does this arrangement imply? A. The fan relay will only energize when the high limit is bypassed. B. If the high limit opens, the fan relay is disabled. C. The high limit controls compressor operation only. D. The fan relay will operate independently of the high limit control. Answer. Correct answer. B. Explanation. A series circuit means both components must be closed for current to flow. If the high limit switch opens, the fan relay is de-energized. B. Acts as a safety interlock. HVAC schematics follow ladder logic, and understanding series versus parallel is key to diagnostics. Reference NEC Article 100 manufacturer service literature for proper schematic interpretation. Question 19. From a practical standpoint, Mr. Ibrahim finds a customer who insists the system needs refrigerant every summer. After leak testing, he finds a slow leak at a service valve. How should he explain the situation? A. Recommend topping off as usual and leaving the leak. B. Inform the customer about the leak, repair it, and explain the EPA regulations. C. Replace the condenser coil even though the leak is small. D. Suggest switching to a different refrigerant to avoid future issues. Answer. Correct answer. B. Explanation. Ethical and legal conduct requires informing customers about leaks and repairing them. EPA 608 mandates leak repair for comfort cooling systems exceeding thresholds. Topping off A is illegal. Replacing coils. C is excessive for a service valve leak. Changing refrigerants. D is not a solution. Effective communication builds trust and ensures compliance. Question 20. Examining the consequences of short cycling, Mr. Ortega inspects a system where the compressor runs for 1 minute and stops, repeating continuously. What control issue could cause this? A. Oversized evaporator coil. B. Faulty thermostat placement near a supply vent. C. Compressor windings shorted to ground. D. TSV sensing bulb loose from the suction line. Answer. Correct answer. B. Explanation. If the thermostat is too close to a supply vent, it quickly satisfies the set point, causing short cycling. This control issue reduces efficiency and strains components. Oversized coils A might cause temperature imbalance but not rapid cycling. Shorted windings C cause electrical faults. A loose TSV bulb D affects superheat, not cycling. Proper sensor placement is defined in manual ZR and manufacturer specifications. Question 21. In comparison with normal operating conditions, Mr. Daniels notices a walk-in cooler that fails to reach 38 and shows high suction pressure with low superheat. What is the most probable issue? A. Evaporator fan motor failure. E. TXB overfeeding refrigerant. C. Compressor valves leaking internally. D. Non-condensables in the system. Answer. Correct answer. B. Explanation. High suction pressure and low superheat point to overfeeding by the TSV, where excessive refrigerant enters the evaporator. This prevents proper vaporization, reducing cooling efficiency. Evaporator fan failure A usually leads to freezing or uneven temperatures. Valve leakage C reduces head pressure but doesn't lower superheat. Non-condensables D affect high side pressure more than suction side. Refer to ASH Refrigeration Handbook and ACAT troubleshooting protocols for proper diagnosis. Question 22. In response to a failed scroll compressor, Mr. Holt prepares to install a replacement. What additional action must he take to prevent acid-related failure of the new compressor? A. Flush only the suction line with alcohol-based cleaner. B. Replace the filter dryer and conduct. A deep vacuum. C. Use the same oil from the old compressor for compatibility. D. Increase refrigerant charge to exceed superheat levels. Answer. Correct answer. B. Explanation. Replacing the filter dryer and pulling a deep vacuum is essential after a burnout to remove acids and moisture. This protects the new compressor. Alcohol flush A may not fully neutralize acid. Reusing old oil C contaminates the new unit, increasing charge. D. Without cause is dangerous. Reference RE Guideline K and EPA 608 for proper compressor replacement procedures. Question 23. Upon closer examination, Mr. Whittaker compares two identical rooftop units. One consumes 15% more energy despite cooling the same space. What should he evaluate first to determine the cause? A. Electrical grounding of the main panel. B. Total equivalent length of refrigerant lines. C. Superheat and subcooling performance. D. Condenser orientation relative to sunlight. Answer. Correct answer. C. Explanation. Evaluating superheat and subcooling is essential to determine whether the system is charged and operating efficiently. Improper charge causes longer runtimes and higher energy use. Grounding A rarely affects energy draw unless there's arcing. Line length B matters during install but is less likely to vary. Sunlight D can affect performance, but refrigerant diagnostics come first. A CAS system performance. Support charge analysis as the primary check. Question 24. The common thread among electrocution accidents in HVAC is improper power isolation. Mr. Russell is replacing a 240 contactor. What is his best course of action to stay compliant with safety law? A. Shut off the thermostat and proceed. B. Trip the breaker and verify using a voltage tester. C. Cut the wires individually while wearing gloves. D. Disconnect one leg of power and monitor for heat. Answer. Correct answer. B. Explanation. OSHA 1910.333 and NFPA 7-tie require isolating power and verifying absence of voltage before electrical work. Shutting off the thermostat A does not de-energize the system. Cutting wires C without testing is extremely dangerous. Removing one leg D still leaves voltage present. Mr. Russell must follow lockout-to-gout protocols and test with a category or thurated meter. Question 25. Historically speaking, why is short cycling in a packaged unit often attributed to faulty sensor placement? A. The sensor reads the wrong ambient temperature. B. The sensor is too close to a supply register. C. The sensor controls the reversing valve. D. The sensor is set to anticipate mode. Answer. Correct answer. B. Explanation. Sensors placed too close to supply vents get false readings and prematurely end cooling heating coils, causing short cycling. Ambient sensors A serve different purposes. Reversing valve sensors C exist only in heat pumps and don't control space temperature. Anticipator settings D influence staging but not short cycling caused by airflow. Refer to manual ZR and thermostat installation standards. Question 26. By comparing a walk-in freezer with rapid ice buildup to a correctly operating unit, is Wallace suspects a defrost issue. Which condition best supports her diagnosis? A. Frost is only on the evaporator's lower half. B. Condenser fan cycles on and off irregularly. C. Suction pressure is lower than design. D. Ice is forming on door gaskets. Answer. Correct answer A. Explanation. If only part of the evaporator is frosted, it's a sign that the defrost cycle isn't clearing all ice, restricting airflow. Irregular condenser fan cycling B may be normal under varying loads. Low suction C is symptom but not cause. Door gasket frost D indicates infiltration, not defrost failure. Reference NATE commercial refrigeration standards and manufacturer defrost protocols. Question 27. Taking into account voltage drop across a contactor, Istakim measures 240 on one side and 215 on the load side. What conclusion should he draw? A. The system voltage is incorrectly grounded. B. The contactor coil has shorted internally. C. The contactor contacts are pitted and causing resistance. D. The transformer secondary is failing. Answer. Correct answer C. Explanation. A 15 drop across a contactor suggests resistance at the contacts, typically due to pitting or carbon buildup. Grounding issues A would affect all readings. The coil B controls contact closure, not voltage through the contacts. Transformers D serve the control circuit, not the high voltage load. NEC 430 and HVAC electrical diagnostics guidelines recommend replacing pitted contact. Prevent voltage loss and overheating. Question 20. The validity of a technician's diagnosis hinges on understanding thermodynamic principles. Ista Sanchez reports that heat is removed from conditioned space and expelled outdoors. What law of thermodynamics supports this? A. Zeroth law. B. First law. C. Second law. D. Third law. Answer. Correct answer C. Explanation. The second law of thermodynamics states that heat naturally flows from hot to cold, and in HVAC systems work via the compressor is required to move heat against that gradient. The first law B addresses energy conservation, not directionality. Zeroth law A defines thermal equilibrium. The third law D deals with absolute zero, not practical HVAC operation. This concept is foundational in fundamentals and physics-based HVAC instruction. Question 29. The contemporary view of technician safety emphasized PPE compliance. During a refrigerant recovery on a rooftop, Isbeck forgets her gloves and safety goggles. What hazard is she exposed to? A. Electrical flashover. B. Ammonia vapor exposure. C. Liquid refrigerant causing frostbite or blindness. D. Co-inhalation leading to hypoxia. Answer. Correct answer C. Explanation. Most refrigerants are stored under pressure and release as low-temperature liquid, which can cause frostbite or eye damage. PPE, including gloves and goggles, is mandated by OSHA 1910.132. Ammonia B is only used in industrial systems. Code D isn't concerned unless large quantities displace air. Electrical flash A requires arc-fault exposure. Manufacturers and 108 guidelines stress PPE during recovery. Question 30. To illustrate this point, Mr. Grayson is brazing copper lines on a new installation. He wraps a wet cloth around the service valve body before applying heat. What is the purpose of this action? A. To expand the pipe for better capillary action. B. To prevent oxidation inside the valve. C. To protect internal components from heat damage. D. To eliminate water vapor inside the line. Answer. Correct answer C. Explanation. Wrapping with a wet rack protects sensitive components, especially Teflon seals and Schrader cores, from heat damage. It does not prevent oxidation. B. Which is handled by nitrogen purge. Capillary action is driven by fit. not water. Water vapor D must be removed via evacuation, not rags. Refer to ASES brazing standards and manufacturer service manuals for proper brazing practices.